Unit 1.6 Photoelectron Spectroscopy. The photoelectron spectrum for the element boron is represented above. Which of the following best represents how the spectrum is consistent with the electron shell model of the atom? So for this problem, we're looking at the element boron. And if you take a look at this is called photoelectron Unit 1.6 Photoelectron Spectroscopy. The photoelectron spectrum for the element boron is represented above. Which of the following best represents how the spectrum is consistent with the electron shell model of the atom? So in this problem, we're looking at the element boron. And if you take a look at this is called photoelectron spectrum. So in photoelectron spectrum, it's always gonna have binding energy on the x-axis and relative number of electrons in y-axis. And this is representing the element boron. And it's represented like this because the photoelectron spectrum is always gonna be based on the electron configuration of the atom. Unit 1.6 Photoelectron Spectroscopy. The photoelectron spectrum for the element boron is represented above. Which of the following best represents how the spectrum is consistent with the electron shell model of the atom? So in this problem, we're looking at the element boron. And if you take a look at this is called photoelectron spectrum. And in photoelectron spectrum, it's always gonna be having binding energy in the x-axis and relative number of electrons in the y-axis. And photoelectron spectrum is always gonna be based on the electron configuration of that element. So since this is representing element boron, we're gonna take a look at the electron configuration of boron. So boron is here. And the electron configuration for the boron is going to be 1s2, hydrogen and helium, 2s2, lithium, beryllium, and boron. So it's going to be 2p1. 1s2, 2s2, 2p1. So that's the electron configuration for the element boron. And let me write it down again here. S2, 2s2, 2p1. So in this photoelectron spectrum, it has 3 levels, 1, 2, 3. And this first peak ends in the 2 level. And the second peak also ends in 2 level. And the third one ends in 1 level. So if you take a look and compare it to the electron configuration, we can notice that it follows this number. And it's the number of electrons. So this has 2 electrons, 2 electrons, 1 electron. And it's going to be representing 1s2, 2s2, 2p1. And the reason why these has a lot of space between each other, it's because if you take a look at the periodic table, these are in period 1 and these are in period 2, so they're in a different period. And each period, if you go into the next period, each period has different energy, like they have a lot of energy difference between each other, and that's why this has a lot of space between each other, a lot of binding energy difference between each other. And so that's it. And if you take a look at the answer choices, we're going to see and look for the option that best represents how the electron is consistent with the electron shell model of the atom boron. So option A, the spectrum shows an odd number of electrons. this is not accurate to explaining why this photoelectron spectrum is representing boron, because any other element could have odd number of electrons, and it doesn't mean that it always has to be boron. And option B, the spectrum shows a single electron in the 2p subshell. It has a single electron, and it is accurate, and it is best explaining how the spectrum is consistent with the element boron. Because if you take a look at the periodic table again, the only element that has one electron in the p subshell is boron. It's the boron only, and this is it. Single electron in the 2p subshell. Single electron in the 2p subshell. It's always going to be boron. It doesn't represent any other molecule, and it's specifically talking about the 2p level. So it's going to be boron. And option C, the spectrum shows equal number of electrons in the first and second electron shells. It's accurate that these two represent the same number of electrons, which is 2. However, it can be any other element that's not boron. It's not specifically talking about the element boron, therefore it is not accurate. Option D, the spectrum shows 3 electrons with the same binding energy in the second electron shell. So in the second electron shell, we have 2s2 and 2p1. It is true that these two have total number of 3 electrons. However, they don't have the same binding energy. So in here, the binding energy is the x-axis, and they have a difference in binding energy. They're not the same. They're not like this. They have a difference, and they don't have the same binding energy. Therefore, this option is also not accurate, leaving us with the option B.